Case study, Transforming Cybersecurity with AI, a case study of predictive capabilities, ethical challenges, and adaptive strategies at CyberGuard Inc. Cybersecurity is on the brink of a transformation, with AI-driven threat intelligence enhancing predictive capabilities, enabling real-time response, and automating threat detection processes. In the offices of CyberGuard Inc., a leading cybersecurity firm, the integration of AI into their threat intelligence systems marks a significant shift in their approach to tackling cyber threats. CyberGuard Inc., led by CEO Emily Chang and CTO Raj Patel, finds itself in the middle of an evolving cyber landscape. The volume of malicious activities targeting their clients has increased exponentially, and traditional methods of threat detection and response are no longer sufficient. Raj, an advocate for cutting-edge technology, champions the adoption of AI-driven solutions to combat these sophisticated threats. The firm's data scientists, including lead analyst Dr. Hannah Lee, have been working tirelessly on developing machine learning models that can predict and identify emerging threats. Dr. Lee's team utilizes supervised machine learning algorithms to analyze vast amounts of data from network traffic, user behavior, and historical attack patterns. Do these machine learning models truly outperform traditional methods in identifying threats, or are there scenarios where older techniques still hold an advantage? Interestingly, their machine learning models show promising results, but with a catch, data quality is paramount. Dr. Lee emphasizes that biased or incomplete data can skew results, leading to inaccurate threat predictions. How can CyberGuard ensure the diversity and quality of the data used to train these AI models? This question leads the team to establish robust data validation protocols and continually update their training datasets with diverse and comprehensive information. Natural language processing emerges as another powerful tool in their arsenal. By analyzing unstructured data sources like social media, forums, and dark web marketplaces, CyberGuard's NLP models can detect discussions about vulnerabilities and exploits that traditional threat intelligence might miss. This proactive approach offers a significant advantage, but it raises another question. What ethical considerations should CyberGuard take into account when monitoring these platforms? The team decides to implement strict ethical guidelines to ensure that their data collection respects privacy rights and does not infringe on any legal boundaries. Advancements in deep learning, particularly in anomaly detection, also play a crucial role. Deep learning models like convolutional neural networks and recurrent neural networks analyze network traffic in real time, detecting unusual patterns indicative of cyber attacks. However, how can the team ensure these models are continually learning and adapting to new data effectively? Regular retraining and validation with fresh data become critical practices to maintain the model's accuracy and relevance. Automation becomes a game changer, reducing the time it takes to identify and mitigate threats significantly. Automated systems handle routine tasks like patch management and incident response, allowing CyberGuard's cybersecurity professionals to focus on more strategic activities. How can the firm balance automation and human oversight to maintain a high level of security without becoming overly reliant on AI? The answer lies in a hybrid approach, where automated systems handle routine tasks, while human experts manage complex decision-making processes. Raj further explores AI's ability to simulate potential attack scenarios. Techniques like adversarial machine learning and reinforcement learning enable AI models to simulate various attack vectors and evaluate the effectiveness of existing security measures. This capability provides valuable insights into potential vulnerabilities. But what measures can CyberGuard take to protect their AI systems from adversarial attacks? The team decides on a multi-layered defense strategy, including robust validation techniques and continuous monitoring of AI model performance. Enhancing threat hunting capabilities is another focus area. Traditional threat hunting involves manually searching for indicators of compromise, but AI augments this process by analyzing large datasets to identify patterns and anomalies that human analysts might miss. This raises an important question. How can CyberGuard integrate AI-driven threat hunting with human expertise to create a more effective defense strategy? By combining AI's data processing power with the intuitive insights of human analysts, CyberGuard achieves a more proactive and comprehensive security posture. The integration of AI with blockchain technology represents another promising trend. Blockchain's decentralized and immutable nature ensures secure data sharing and collaboration among cybersecurity stakeholders. AI analyzes blockchain transaction data to detect fraudulent activities or anomalies. However, what are the potential challenges in combining these two technologies, and how can CyberGuard address them? The team identifies the need for scalability and interoperability solutions to ensure seamless integration and effective utilization of both technologies. Despite these advancements, significant challenges remain. Adversarial attacks against AI models pose a real threat. Cyber attackers can manipulate AI models through techniques like data poisoning or model evasion to evade detection. How can CyberGuard mitigate these risks and ensure the robustness of their AI systems? Continuous research and development in AI security, along with regular updates and patches, become essential to safeguarding their models. To conclude, CyberGuard Inc.'s journey into AI-driven threat intelligence reveals both the immense potential and the challenges associated with this technology. By leveraging machine learning, NLP, deep learning, and blockchain technology, the firm enhances its predictive capabilities, real-time threat detection, and automated response mechanisms. However, maintaining data quality, ethical considerations, balancing automation and human oversight, protecting against adversarial attacks, and ensuring seamless integration with existing systems remain critical to realizing the full potential of AI-driven threat intelligence. Raj and Dr. Lee's team reflect on their progress and the lessons learned. They recognize that while AI dramatically enhances their cybersecurity efforts, constant vigilance and adaptation are required to stay ahead of evolving threats. The future of cybersecurity at CyberGuard Inc. lies in a synergistic approach, combining the unparalleled speed and accuracy of AI with the intuition and strategic thinking of human experts.